Let's imagine a pretty good looking guy, and he's attracting two girls at once. But predictably, they find each other kind of repulsive. So what's the best way to arrange those two girls about the guy? Well, in a linear arrangement, where the two girls are in a straight line, and the angle between them, defined by the two bonds to the two girls, is 180 degrees. That's a linear arrangement. Okay guys, let's imagine a really cute girl, Miss Malaysia, for instance. Well, she might at any time have 3 guys interested in her, and probably they're going to find each other repulsive. What's the best way to arrange these 3 guys about the girl? Well, if we draw a triangular arrangement and put the girl right in the middle, then it's impossible to get the guys any further apart on average. And that we call a trigonal arrangement. And if we look at the bonds between any 2 guys, they will form an angle of 120 degrees. It's simple geometry because 3 times 120 is 360. Now, as they say on social media, it gets complicated. There is a guy. I don't know what's special about him. I just know he has what I don't. There are 4 girls chasing him at one time. How could you space these 4 girls so they're equidistant and on average as far apart as they possibly can be? To answer that question, we need to draw a tetrahedron. The way to draw a tetrahedron is not quite obvious, but you start at the North Pole and you draw towards the South Pole, but maybe a little bit on the side. And then you come from the North Pole again, you go down and you break the line and come across. And then you join up the corners. Okay, we've got our tetrahedron. We can put the guy in the middle and the 4 girls at each corner, at each apex. Now, if we look at the guy, and the way he's bonding to these girls, well, it's all equivalent. And actually the bond angle between any 2 girls would be 109 degrees and 28 minutes. That's the magic number for a central point in a tetrahedral arrangement. The big picture is that carbon combined with 2 things, it can combine with 3 things, or it can combine with 4 things to get that precious stable octet. When it combines with 2, it gives a linear arrangement. Bond angle, 180 degrees. When it combines with 3, it gives a trigonal arrangement. Bond angle, 120 degrees. And when it combines with 4, it gives a tetrahedral arrangement, which I can't do because I don't have enough arms really. But the bond angle is 109 degrees. Now there's a problem, because available to the carbon is an s and 3 p orbitals. If, for instance, in a linear arrangement, we want to maximize the bonding, the s orbital will work, and one of the p orbitals will be pointing in that direction. That's great. But the other 2 will be perpendicular. They're as bonding as they are anti-bonding. Useless. What about in a trigonal arrangement? Well, the s orbital works too. And 2 of the p orbitals sort of work, but they're at 90 degrees to each other. And remember, the angle, the magic angle, is 120 degrees. So we can use those 2 p orbitals, but we can't use the 3rd orbital. We can use an sp2 combination. In a tetrahedral arrangement, 109 degrees and 28 minutes, we can use the s orbital again, and we can use all 3 p orbitals, but only one of them will really point directly to the hydrogens. So we've got to do something special to mix them up and use the sp3 combination. And that is the key to hybridization. And that is the next video. Students learn organic chemistry by remembering some key facts, learning pivotal concepts, then applying the concepts in problems until the concepts are mastered. To help with that, I'm preparing an ebook on hybridization and bonding to be published on iBooks for the Mac and Amazon Kindle. The full workbooks, Sophomore Organic Chemistry by Inquisition, are available from Amazon and from the byinquisition.org website, where the answers can also be found. Thanks for listening. Bye.